Hello, we are going to do some example problems on how to solve exponential and log equations. So there's a couple different methods, and this assignment goes through several of them. So the first one we're going to look at is how to solve by using the definition of logarithms. And the definition of logarithms, we're talking about this idea here. So when you have an equation log base b of x is equal to y, that is equivalent to saying that b to the y power equals x. In other words, b multiplied by itself, y times equals x. Log's sort of the opposite of that idea. How many times do you multiply by b to get x? The answer to that is y. So this idea that these equations are equivalent is useful when we're solving equations that look like either of these, because we can rewrite them in the other form, and that helps us solve for x. So here's our first example. We have 5 to the x equals 100, and we want to know what x is. So in other words, how many times do we multiply by 5 to get 100? So the way we're going to do this using the definition of logarithms is we're going to rewrite this. So first to color code it so it kind of matches the slide on the previous page. So we got 5 is our base. We have the power of x, and we have 5 to the power of x is equal to 100. And so I'm going to rewrite that using my log notation. So log base 5 of 100 is equal to x. Okay, that is this equation rewritten in log form. And what's nice about this is you can see it tells us what x equals. X equals log base 5 of 100. So if I just knew what log base 5 of 100 equaled, then I would know what x equaled. And there's a couple ways of figuring out log base 5 of 100. One way is you can use the properties of logs like we talked about in the last lesson and calculate them that way. Or honestly, in this lesson, you're welcome to just use your calculator and type in log base 5 of 100 and see what that equals. So let's do that real quick. So right here on my calculator, I'm just going to type log base 5. And by the way, to get this little subscript 5 that you need, you just use your underscore button. So shift and the minus sign that's next to the 0 will make that happen. There's also a log button in here somewhere. I think it's under functions. If you go to miscellaneous, there it is. You can type in log and it'll give you the subscript that you can just put your cursor in there and type. But anyway, so log base 5 of 100 is 2.861353111615 and keeps going forever. But and that's going to happen a lot of times. You're going to get decimals that just go forever. So we can just round this. We'll say it's about 2.861. So x is equal to 2.861. Now, if you wanted an exact answer, you could just leave it like this or write some equivalent form rather than having to round a decimal. Okay, we're going to do another problem now, similar, but this time we have an equation written in log form, and we're going to use the definition of logarithms to change it back to exponential form. So we're going to go the other way. So we have log base 3 of x is equal to 8. Okay, so according to my definition of logarithms, that equation is the same thing as saying 3 to the 8th power is equal to x. Okay, now again, like last time, you can see that this is telling me what x is. X is equal to 3 to the 8th power, or 3 times itself 8 times. So you could figure that out, 3 times 3 times 3 times 3 times 3, you know, whatever, 8 times. I'm just going to go to my calculator, and let's do 3 to the power of 8. And I get 6,561. So x is equal to 6,561. So there you go. Okay, next we're going to look at an example of how to solve by graphing. So here's our example. We have to solve the equation 10 to the x equals 80. And to do that, we're going to look at this graph right here. This is a graph of y equals 10 to the x. Now, the similarity between this equation for the graph and the equation we're trying to solve should be kind of obvious, right? So basically, we're trying to figure out what does x have to be for y to equal 80 in this graph. So here's the y-axis, and here's where y equals 80. Let's make this a different color so we can see it better. So if I just look at my graph here, it looks like that happens right there. And what's the x value that's going to make that happen? So if I look down here, it looks like, what is that? So this is 1, this is 1.5, that's 2. So it looks like these are counting. Each box is 0.1 higher. So this would be 1.5, 1.6, 1.7, 1.8, 1.9. Now, this is just approximate, right? This isn't going to give me a very accurate answer. If I want an accurate answer, I'm going to have to either increase my graph, like zoom in on it, or I'm going to have to use a calculator and do some other method. So graphing doesn't give you very accurate results, but it can be useful for finding a quick answer to the problem if you just need an approximation. So this tells me that x should be about 1.9. And sure enough, if you put in 10 to the 1.9 power, so let's go ahead and do that. So 10 to the 1.9, and I get 79.4, which is pretty close to 80, right? So this obviously is maybe a little higher than 1.9. But again, for an exact answer, I'd probably have to do some different method. Okay, so now we're going to talk about how to solve by using logs as inverses. So to kind of demonstrate this idea, let's look real quick at a problem like x squared equals 100. If you were to solve this using a process of inverses, you would probably do something like take the square root of both sides. And what that does is square rooting the square kind of undoes each other. There are some details to talk about there that we're not going to go into with this video, but by square rooting both sides, you're going to get the x equals 10. Okay, now there's some details that I've kind of washed over here, but the idea is that using something to undo something else can be used to both sides of the equation. And so here's a problem where we're going to undo this sort of 5 to the power of x operation that's going on here. And the way we undo that is with log base 5. So I'm going to go ahead and take the log base 5 of both sides of this equation. So log base 5 of x on the one side, and then on the other side, I'm going to take the log base 5 of 100. And I'm using parentheses just to make it clear what's inside the log and what's not. But there's our equation. So we just took the log of both sides, and you can kind of see the original equation still there. Okay, it's basically the same thing that we got up here. But what we've done is we've applied a log base 5 of both of these things, and we've gotten this. Okay, now that might look worse than it was before, but we're now going to call on our log properties. So you might remember these guys from the last few lessons. And the one that we're going to focus on for this problem is this log of a power rule. So it says that log base b of x to the k is equal to k times log base b of x. Well, that's kind of what we got going on here, right? We have log base b, in this case log base 5, of something to a power. In this case, our something is a 5, and it's to the power of x. And so this is telling me that I can rewrite this as that power times the log base b of x. So in this case, that is going to end up being the exponent, which is x, multiplied by log base 5 of 5. Okay, so we've applied the power rule to basically bring this x out in front, which gives us this new expression, which is still going to equal log base 5 of 100. Okay, that hasn't changed. We just changed this left-hand side to, instead of being log base 5 of 5 to the x, we changed it to something that's equivalent, which is x times log base 5 of 5. And now the log base 5 of 5, you'll probably notice that that is equal to 1. So I got x times 1 is equal to log base 5 of 100. Okay, and so that's basically saying that x on this left-hand side is equal to log base 5 of 100 on the right-hand side. And again, now you can use your calculator to figure out what exactly that is. But something about this idea here, so this worked because we used the same log base as the base of the exponent. So we did log base 5 of 5 to the x power. That's always going to basically simplify this down to whatever the exponent is. And so this idea, even though it seems kind of cumbersome, right, we can actually skip all of this and just go straight to this. But really what we could think of this as is the log base 5 and the 5 to the x, the base of the exponent and the log of that number are canceling out. And so we're basically just getting x equals log base 5 of 100. And we can kind of skip all this intermediate stuff and just go straight to that. Now notice this is basically the same thing as rewriting this in log form. So at this point, that might not seem too different than using the first method we talked about, but it is different technically speaking. So on these problems we've done, they really are basically the same method. But there'll be problems we look at in the next couple lessons where these methods actually look different depending on how you apply them and what you apply them to. So it's good to think about it in those two different ways, using logs as inverses versus using the definition of a log to take this equation and rewrite it like that. So try your best as you do these lessons to stick to the method prescribed so you can get practice doing both and get a better feel for it. And as always, if you have any questions, email me, let me know.